LISP network virtualization and multi-tenancy in parallel model. What is the parallel model? You know that in previous video we learned about the shared model. In shared model we are using only one RLOOK space, but in the parallel model we have multiple RLOOK space, and actually we have multiple LISP infrastructure. Okay, let me to talk about the parallel model. First, I'm going to explain the parallel model. After that we will configure it, and finally we will learn it with more detail. You know that in this scenario we have, for example, XTR1, XTR2, and also MS and MR in the router tree. Okay, and you know that the XTR1 and XTR2 should advertise their EIDs to the MS, and in the shared model, let me to review the shared model, we are advertising the EID of the, for example, router 1 192.168.10/24 with the instance ID. You know it, okay, and you learn about it with the instance ID of the for example 1. Let me to write here IID1, okay, to the mapping server with one mapping for example register message. This is the map register message, and we saw it, and also we configured it. Okay, you know that here the R1 should also advertise the another map register. In the second map register we have 192.168.10/24, again with the instance ID of 2. Assume that here we are using the instance ID of 1. Let me to write here IID1, and also here IID2. okay, we are configuring for each VRF one unique instance ID, and then also beside of the EID and also the IID, okay, we are advertising the RLOOK. For example, in R1 we had only one RLOOK. RLOOK is quad 1, okay, and we advertise the quad 1 to the R3 as the RLOOK for both of these EIDs, RLOOK quad 1, okay. And also here we have the RLOOK of quad 1. This is the map register from the R1 in the shared model. RLOOK, again quad 1. Okay, you know that here we are using only one RLOOK for reaching to the, for example, both of these two VRFs. This means that we are using a shared model. Shared model means with one shared RLOOK address we can receive traffic of for both VRF, okay, and this means we can receive the traffic of both VRFs with one IP address, and after that with the instance ID we can identify the traffic is receiving for which VRF. This is the for example a shared model. But in parallel model we are doing with a little difference this function. Look at here in the shared model we have only one MS and one MR, and also in R1 we have only one LISP instance. Okay, now let me to talk about the parallel model. In parallel model, we don't use one RLOOK address for both of the, for example, VRFA and VRFB. Here, in parallel model, we have two LISP instances in two different underlay. For example, you can configure one RLOOK as quad 1, okay, and this is residing in one VRF. For example, VRF, let me to write to give a name, VRF RLOOK 1. This is the name of VRF only, and after that we have another VRF for example RLOOK 2, okay, and we are using another loopback IP address for the RLOOK 2. This means that we are advertising one RLOOK for the 192.168/24 with the IID of 1 and in the VRFA, that is the quad 1. But for VRFB we are using another LISP instance. Actually we can say that here we have two RLOOK space. The first RLOOK space is the RLOOK space for the for example LISP site 1, and the second RLOOK space is using for the LISP site 2. In the Lisp parallel model, we virtualize each Lisp site and the mapping system and segment the core network to support the multiple Lisp VPNs. Completely separate Lisp logical infrastructure is shared on top of the same physical infrastructure. You will understand the detail of this method. Let me to give you more explanation about the configuration. You can better understand it. Look at here. Here we have now one link between the router 1 and router 3 and also router 2 and router 3. We need two separate virtual networks in one physical network because I'm going to use two Lisp instances. How we can do it? Look at here. Assume that in the router 1 I am configuring two VRF. Let me to configure them, because with this function you can better understand. The first VRF is the VRF RLOOK1. I will talk about the configuration, but for now I'm going to configure two VRF, VRF RLOOK1 and VRF RLOOK2. This is the name. RLOOK1 and RLOOK2 are the names. Also in the R1, this is the configuration of the R1. After that we will configure them. And also we have two interface loopback, interface loopback 0, okay, with the IP address of the 1111, okay, slash for example loopback 1. This is the interface loopback 1 with the IP address of the quad 1 slash 32, and then another interface loopback 2 with the IP address of the 1112/32, and after that this is the member of the VRFA or VRF RLOOK1, and this is the member of the VRF, okay, VRF RLOOK2. Okay, and after that I'm going to use the quad 1 for the VRFA as the RLOOK address space, and the interface loopback 2 for the for example VRFB. You know that in the previous scenario, in the shared model, we use only one RLOOK for all of the VRFs, but now I'm going to use different RLOOK for the different VRFs. Okay, and after that here in the ETH00 we need two sub interface, because I am going to create two different networks, two different virtual networks in one physical network. You know that we can configure two sub interface on the ETH00 interface ETH001, and here we can configure the tag 1 .1q tag 1 and also one IP address 10.1, okay, 10.131/24, and this is the member of the RLOOK1, VRF RLOOK1. Okay, you know that when we are configuring one interface in one VRF for the interfaces on other VRF, we can configure the same IP address. Because of that, let me to configure the interface ETH002 with tag of 2, tag.1q tag of 2 with the same IP address, but in the VRF RLOOK2. Look at here. Now I configure two VRF2, for example VRF here, and after that I assign two ETH001 and 002 to these two VRF, and now we can also configure the VRFA and VRFB. Look at here, we can configure the other two VRF for these two these two first VRFs are VRFs for RLOOKs, but these two VRF that I am configuring now are the VRF for the EIDs. We can configure VRF, for example VRFA, and also VRFB. Okay, and here now we have two VRF for the EID and two VRF for the RLOOK. Now we can select that, for example, with which VRF for VRFA should use which RLOOK address space. For example, you know that when we are configuring the router Lisp here, we can, after some command, we are configuring the database mapping command. But let me first define that from which VRF we should use in the, for example, router Lisp. Here we need two router Lisp instance because we have two RLOOK space. For each RLOOK space, you can use one Lisp instance. For example, I'm going to configure router Lisp 1. In router Lisp 1, we are using the RLOOK space. We call it a locator table. Okay, locator table is VRF RLOOK1. This means the router Lisp 1, the first process of Lisp, is using the RLOOK space of the VRF RLOOK1. Okay, And after that, here now we can configure the same command that before we configured, eid table, and then for vrf, okay, then the vrfa, and then instance id 1, instance id, okay, 1. And then here you can use again database mapping command with the similar configuration that you learned before, database mapping, and after that the 192.168.10/24,